Okay, thank you for this nice introduction. I just hold it. Yeah, I will start to remind you of a problem that we all face with research software, which I hope you're all aware of. First off, it's hard to get funding for software. It's hard to find qualified developers because most of the time it's scientists who to some extent become developers. Also, very often the software is somewhere internally developed, somewhere hidden, is not really well publicly visible. So it's usually, from my experience, that people tend to not so much reuse the work of others that's already there because they say, oh, that's too complicated, we do something similar, and then it revolves in the next complexity. They say, oh, this is what crap, we can do it better, and then they do it again instead of maybe working together to create something better. And maybe you've seen this graph before. We have this in the feeling that for most of the projects that are around there are just a few developers, most of the time it's just one. And once this person leaves research, there's a paper at the end, but the project usually dies. And of course, better metadata for software cannot solve all of these issues, but it can at least help with that we can better find software that's already there, that's currently developed, to find the people who are doing these things, who are currently the experts, and also it can help to understand the software a little bit better, why, with what intention it was written, what's supposed to do, and hopefully we can at least increase with better metadata, therefore the reuse and collaboration within research of software. So that's like the overall topic. In my talk, I will first tell you something about what the Helmholtz knowledge graph is, so what I'm doing there. And then in the second part, I will show you some more software-specific insights that we have in there, and some ideas about how one could improve the status quo and why we're all doing this. So first off, I'm from the Helmholtz metadata collaboration, so we are in the Helmholtz scope, and you probably know Helmholtz. It's a large research organization with 18 different centers, and all these centers have their own infrastructures all over Germany, all kinds of infrastructures, from code repository, data repositories, their libraries, of course their labs, research infrastructures, and currently there's no way to search through all of them to find what's there, and therefore we decided to create a lightweight interoperability layer, which we call the Helmholtz knowledge graph. So we plan to extract metadata that's exposed by all these different infrastructures, and then to make it more visible and especially work together with the infrastructures to improve this metadata at the source, not just at the graph level, but we want to improve it at the source, and therefore, of course, increase the findability of all these assets, not just on the graph level, but on the whole web overall. And of course, that's a good thing for Helmholtz. How we are going to do this, I've already mentioned. We are basically harvesting the metadata that's exposed in standardized way by these infrastructures, and we combine these records into a graph. There are also other initiatives out there, certain communities. So, for example, I mean the ocean communities who for similar approaches, and one can learn from them, and we try to be interoperable also with other graphs. And of course, for this, we have to be in accordance to certain standards. And in our case, that's schema.org for now that we decided to go on because that's currently the best kind of metadata out there that you can get from a lot of sources. And so currently in the graph, we have a connected of 32 different infrastructure. This includes the libraries, only a few data repositories for now, and all the GitLab instances that Helmholtz hosts, and also we connect to some global sources where we can extract the Helmholtz part out of it, so for example from data side. So in total, I mean, to kind of give you an idea, we have about 2 million records, and I mean, if you talk about the F-graph size, we are talking about 7 million tuples currently. For this, we have, of course, a Sparkle endpoint for this graph, and we have a front end where we've built a full text search index on top of this metadata, so you can now go to this website and you can federally search through all of these things. So now if you're looking, for example, for climate research, you will find the people, you will find the papers, you will find the software, you will find the data sets, and you can see how they're connected, if they're nice, if the connections exist, of course, in the metadata which was provided to us. Now, to the second part. How we zoom in on software, what's data status. In general, from my view, the software case is already quite good and easier than, for example, I mean, the data side. And the reason for this, there are already quite some standards out there that one could use. So, for example, I advise you to use citation-CFF files and, if possible, also generate a code meta file. Currently, the tooling there is not so nice, but I mean, the community is working on tools to improve the status there, to make it more convenient and easier to do these things. The software is quite small. Also, of course, a big part of it of Git, and basically it's all on platforms, and already Git tracks a lot of the provenance metadata and software, so there's a lot of metadata that is already there, but not in a linked data fashion, but there's a lot of things that one can use. And also the reuse case of software is quite easy, because usually people want to get the whole part of your software and install it and run it, and not, for example, in the case of the data set, I want to have this part of your data and use it for something completely different that you've never thought of. And therefore, I think this problem is solvable, and one can make here quick and more faster progress actually also, I mean, if the community moves into such a direction. Now to the details of the data pipeline with respect to software. I mean, we have a data pipeline set up. We use Prefect as a workflow manager, and we have a Git harvester which goes to the API of all these GitLab instances, and it gets all the public available projects, and then it fetches, then it checks if it can find the code meta.json, because that is in schema.org metadata, what we currently require. And if yes, then we just get this metadata. If no, then we clone the repository. We have there's some software to generate a code meta.json file from the information that might be there, scattered in the repository, and then we upload this into the graph. and also in the future we try to uplift the data, but more on this later. Now to give you a quick overview on some of the things that we see. One thing I've already mentioned, and you probably, if you're longer in the field, experience, there's a general uptake in Git, so there are more new repositories created each year. This has wide use now with research software, and this is a very good thing. I can confirm that we have a bus factor of 1, so most of the projects have a single contributor, and also, of course, expected not all of the projects, so about 7,800 repositories, not all of this is software, but from this project about 600 are active, 800 had no release yet or will never have a release, and not all of these have licenses, and we mostly see some open source licensing with MIT the most promising, some use tags and so on, so we can look into these things. If you are concerned about languages, most of these repositories have some Python code in them, but of course in research you find a whole, and this table goes on. Basically you find everything that's out there. Now what's the status on the metadata? Most of the metadata, not only for software but also from the NASA assets that we get, is not semantically well annotated. So if you would plot, a graph on this, you see, for example, the Fortune Center Wheeler here is the affiliations is just a string, and people use different strings, so you're not completely sure if this is the same thing. It's not typed, so you don't know if this is an organization or not, and there's no identifier given for it, so you cannot map these nodes together. Just simply in the linked data fashion, so you get kind of bad linked data. The same, for example, like here, Elka Mustermann is probably the same as the author, the contributor here. And of course, what we would like to have is this. And so that you have IDs, ORCIDs for persons, and some other PIDs used for like organizations and things, and of course for your software also. And yeah. And this is where we try to get. So we're talking about data providers, how to improve this. Of course, we can do entity resolution now on the graph level compared to other metadata and so on that we have. But again, our goal is to talk back to the providers and do this. And of course, I'm not doing all this alone. These are the people who are working on this project, some on the technical side, some on the community side. And I want you to take home that think a little bit what you can do with this metadata. So for example, my dream would be, we have this information, I could write a helper bot, for example, not just for metadata, but also for research software development to check maybe if your license is valid according to your dependency, for example, or you could have a bot that tells you, here you're big like actual project, don't you want to create a citation file? We've seen maybe dissertation publication out there with the same name. Maybe there's an example from citation file, maybe adjusted and committed, or the same for commit things. One problem we face, of course, we want to include GitHub, but it's very hard to extract, let's say, what are the Helmholtz projects on GitHub, and take home. There's now a Helmholtz knowledge graph. You can use for search. If you use schema.org, and now's kind of the time you can, as a use case, so for you, you could go there and search for other developers, other projects, other things that are not very publicly available in Helmholtz. Thank you.
Thank you very much for this great